everyone, here we are going to continue with exercise 12a of the chapter Midpoints and its Converse. We have already did till question number 12 in our previous video. Now we are going to continue with question number 13. Now here in question number 13, as per information given in the question, we have a triangle ABC in which this AD is median and this E is a midpoint of this side AD. Then we are having a line from B which passes through E and join AC at F. Now we have to show AC is 3 times of AF. So very first of all, for this we are going to do a construction by making a line from D parallel to this BF. So here let this one be point G. Now in triangle BCF we have D as a midpoint of BC and DG parallel to BF. In triangle BCF we have D is a midpoint of BC and DG is parallel to BF. So as D is midpoint of BC and DG is parallel to BF, so by converse of midpoint theorem we get this DG bisects the side CF, that is the CG equals to FG, and here we get the relation CG equals to FG. Now we'll move to triangle ADG. In this one we are having E as a midpoint of AD and this EF will be parallel to DG. So here in triangle ADG we have E as a midpoint of AD and EF is parallel to DG. So as E is midpoint of AD and EF is parallel to DG, therefore this EF is going to bisect the side AG, and by that we get AF equals to FG. So on getting the relation AF equals to FG, we can take this one as equation number 1 and this one as equation number 2. So from equation number 1 and 2 we get E equals to FG equals to AF. That is, this all the three sides are equal. So we can write this one as AC equals to 3 times of AF. Hence proved. Now let's see question number 14. Now here, as per information given in question, we are having a triangle ABC in which D and F are the midpoints of the side AB and AC respectively. And then from F there is a line parallel to AB which is touching BC at E. Now we have to prove this BDFE is a parallelogram. So as D and F are the midpoints of the side AB and AC, therefore we can apply midpoint theorem to get DF is parallel to BC. Now we see that DF is parallel to BC, therefore it will be parallel to BE also, and here we are having FE parallel to DB. So as both the pair of opposite sides are parallel, therefore this will become a parallelogram. In triangle ABC we have D and F are the midpoints of the side AB and AC respectively. It was given to us. So by midpoint theorem we get DF is parallel to BC. So as DF is parallel to BC, this can also be written as DF is parallel to BE. Also FE is parallel to AB. So here we have FE parallel to AB. Now as this FE is parallel to AB which was given to us, this FE will also parallel to DB. Now from this relation and this relation we get that both the pair of opposite sides of this quadrilateral BDFE is parallel. So therefore this is a parallelogram. So as both pair of opposite sides of a quadrilateral is parallel, therefore BDF is a parallelogram. Now we have been given with the value of EF as 4.8 cm and we have to find the value of AB. Now as we know that opposite sides of parallelogram are equal, therefore this BD will be equals to EF. Therefore we get BD equals to EF as opposite sides of parallelogram. That is BD will be equals to 4.8 cm. Now we know this D is a midpoint of AB. Therefore this AB will be twice of this BD. Therefore AB equals to twice of BD as D is a midpoint of AB. So we can place the value of BD over here, that is 4.8 cm, and this will be 9.6 cm as answer. Now let's move to question number 15. Here, as per question, we are having a triangle ABC in which AD is median and there is a line from D parallel to AB, and we have to show this BE will be a median. For that, very first of all, we will be proving that E is a midpoint of AC. So in triangle ABC, we are having D as a midpoint of BC and this DE is parallel to AB. So by the help of converse of midpoint theorem, we can prove this E is a midpoint of AC. Now in triangle ABC, we are having D is midpoint of BC as AD is median. Then we are having DE parallel to BA. It was given to us. So by converse of midpoint theorem, we have got DE bisects AC. So DE bisect AC means E is a midpoint of AC. As we are having E as a midpoint of AC, therefore we can call this BE is also a median. Therefore BE is also a median from B to the side AC. Hence proved. Now let's do question number 16. Here in this question, as per information given in question, we are having a triangle ABC in which AD is median and E is a midpoint of the median AD. Then we are joining B to E and is produced to the line AC which is intersecting at Q. And we have to prove BE is to EQ equals to 3 is to 1. That is, the ratio of this portion to this one is 3 is to 1. For that, very first of all, we are going to draw a line parallel to this one from here. So these two lines are parallel to each other. Let this one be M. So we are going to draw DM parallel to CA. Now we'll be proving these two triangles congruent, in which this angle will be equal to this one as interior alternate angle. This angle will be equal to this one as vertically opposite angle, and this side equals to this one as E is midpoint of AD. So in triangle AQE and triangle DME, here A will be equals to DE given to us. Then this angle will be equals to this one, vertically opposite angle. Therefore angle AEQ equals to angle DEM by vertically opposite angles. Then we can take this angle equals to this one as interior ordinate angles. Let this one be angle 1 and this one be angle 2. Now to prove these two triangles congruent, we have used this angle and this side. So it is AAS. Therefore triangle AQE is congruent to triangle DME by AAS. Now we can show that ME will be equals to EQ by CPCT, and here we get EQ equals to ME by CPCT. Now we can write this EQ as the half of this whole MQ, and here we get EQ equals to half of MQ. Now we are going to take the triangle BQC in which D is midpoint of BC and DM is parallel to CQ. So in triangle BQC we get D is the midpoint of BC and DM is parallel to CQ. So by converse of midpoint theorem we get DM bisects BQ, and as DM bisects BQ we can write this one as MQ equals to half of BQ. So this portion MQ will be half of this whole BQ. Now here we have seen that EQ is half of MQ. So let this one be equation number 1 and this one be equation number 2. So from equation number 1 and 2 we get EQ equals to 1 by 2 into 1 by 2 BQ. Now we are going to solve it and this will become EQ upon BQ equals to 1 by 4. Now this can be written as BQ upon EQ equals to 4 by 1. If I subtract 1 and from both of the side, this will become BQ upon EQ minus 1 equals to 4 upon 1 minus 1. Now we can take LCM, and on taking LCM this will become BQ minus EQ upon EQ equals to 4 minus 1 upon 1. And on solving this, this BQ minus EQ, this will be BE. So it is BE upon EQ equals to 3 upon 1. That implies BE is to EQ equals to 3 is to 1. Hence proved. Now let's do question number 17. Here in this question we have M as a midpoint of ED as well as of AB, and N as the midpoint of BC as well as of DF. We have to prove this EF is equals to AC. So very first of all we will be taking the triangle ABC in which M and N are the midpoints of the side AB and BC respectively. So in triangle ABC we are having M and N are the midpoints of the side AB and BC respectively. Therefore by midpoint theorem we get MN equals to half of AC. Now as we have did in the triangle ABC, M and N are the midpoints of the side AB and BC respectively. Similarly in triangle EDF, the M and N are the midpoints of the side ED and DF respectively. Therefore, this MN will be half of this side EF. So here in triangle EDF, we are having MN and R the midpoints of the side ED and FD respectively. Therefore, by midpoint theorem, we get MN equals to half of EF. Now let this one be equation number 1 and this one be equation number 2. So from equation number 1 and 2, we see that they both are equals to MN. So we can equate 1 by 2 AC equals to 1 by 2 EF. And here we get 1 upon 2 AC equals to 1 upon 2 EF. This 1 by 2 will be cancelled from both of the side and this will become AC equals to EF. Hence proved. That's all for this video. Thank you.